You should have your worksheet, 7.0 Module 1, Lesson 8, Equations. And, oh, that's white. That's erase. We'll put our names on here. Go ahead and do the same. Okay. Our learning objective today is to write equations to represent proportional relationships. We have already done tables, we've done graphs, we did a little bit of pictures, and I've showed you a couple of equations. Now we're going to be writing equations to represent these situations where we have proportional relationships. Our first one is a large Gatorade is $2 per bottle. The total price may be represented as a multiplication equation. The price per bottle times the number of bottles is the total cost. So what we want to do here is write an equation that involves multiplication and only multiplication to get from these quantities that are involved, unit price, number of bottles, to get to our total cost, just like you would in the store. You know what the price is of a bottle, you select the number of bottles you want from the shelf, and the cashier tells you the total cost based on the unit rate or price per bottle and the number of bottles. Go ahead and write a multiplication equation showing that. Should be just numbers, multiplication, and an equal sign. I will wait while you do that. Okay. Whether you got that or you were stuck, just like it says, price per bottle times number of bottles is the total cost. In this case, our price per bottle is $2. Our number of bottles is 1, and our total cost then is $2. I know that sounds super simple. Stay with me for a while because when we get down to this section at the bottom, when we're talking about variables, it's a little bit of a conceptual leap that we need to make. So we're going to take baby steps there. Okay, go ahead and try to get the equations for the next two here. The multiplication equation for 2 bottles and 3 bottles, each at $2 per bottle, to show what the total cost is. Go ahead, I'll wait. Pause it. And you're back. So, again, the price per bottle times the number of bottles is the total cost. We've got $2 per bottle times, and I'll write it like that this time, times 2 bottles equals $4. In this particular instance, 2 plus 2 would work, but we're using multiplication because proportional relationships involve multiplication. So 2 times 2 equals $4. The next one, $2 per bottle, 3 bottles, $6. So we write $2 per bottle times 3 bottles equals $6. And if we're showing all of our units here, then it's going to look something like, let me write a little thinner there. It's going to look a little bit like $2 per bottle times 3 bottles equals $6. Okay. The last one is the one where we need to take a little bit of a leap. But first off, let me show you a little bit of a little something that may help. So we've seen that if we get one bottle, it's $2 per bottle, $2. 2 bottles, $2 a bottle, $4. We can imagine that rather than writing out a different multiplication equation like this, each time we want to represent a different number of bottles and the total cost that it'll be, that it becomes more efficient to just use a general number, a variable. So we won't know, maybe even going into the store, how many bottles you're going to buy. It might depend on how much money you have in your pocket. So we can say, we can create an equation that shows the relationship between the number of bottles and the total cost. Okay. In this case, and just like before, let me change that. I'm going to underline this probably a couple more times. Price per bottle times the number of bottles is the total cost. And if we look at this statement, we can kind of turn that into an algebraic equation. But first, I am going to take away a couple of lines here and just highlight what we did in saying, I'm going to take away all of these lines here. Okay, no, that one I didn't need to get rid of. Okay, go back to my little lines. So for this first one, the price per bottle, or the unit rate, times, which is right there, the number of bottles, right there, is equal to, another way, is how you normally see that in a problem, $2 total cost. So if I want to draw some fancy lines here, so my price per bottle is this whole row. Let me make that a little thicker to make it a little more fun. Price per bottle. And then I've got the number of bottles. And then I've got the total cost. Okay, and two more little ones to do. Let's see, times, and we all know times. That's going to be a multiplication symbol. And, nope, not orange again. And let me find one that we haven't had. Maybe I already had that one. Is. And that one shows up as equal. So I can go back through here and say 2 times 2 is equal to 4. Price per bottle times the number of bottles is the total cost. And then right here, I have $2 times the number of bottles is equal to the total cost. 2 times 3 equals 6. See if you can do the same thing using the quantities that we've laid them out here. X is our number of bottles, how many bottles we're buying. Y is being represented, or the total cost is being represented with Y. So see if we can write a an algebraic equation that follows these patterns. And I'll wait, pause it while you're working. Okay, and we're back. Like I said, this was the tough part, but hopefully you were able to see those patterns. And let me just, oh, I didn't want to stop that. I wanted this. So we can just continue these down, right? And because just like our unit rate was 2, it's still 2 because that's still the price of the bottles. Number of bottles, though, now we're saying we want to represent any number of bottles, so we're calling that X. And since we don't know the number of bottles, we don't know the total cost, but we do know the relationship between the total cost and the number of bottles, and that is right here. And let's get rid of those, and it is the same relationship as we saw before. 2 bottles times the number of bottles is equal to the total cost. Price per bottle times the number of bottles is equal to the total cost, as we see in the bottom. So let me just write it out separately so it's a little more clear. 2 times the number of bottles, and again, the number of bottles is being represented as X, is equal to the total cost, which is being represented as Y. 2 times the number of bottles is equal to the total cost. We can also write that as Y is equal to 2X. Total cost is equal to the price per bottle times the number of bottles. And I think that makes sense to you when you're at the store. But writing that into an algebraic equation can be a little bit different than just knowing how much you're going to spend at the store. If we want to test this, we can put each of these numbers, 1, 2, 3, into this equation and test them. So if we put 1 in there, we get 2 times 1 equals Y. 2 times 1 equals 2, just like it shows up in there. If we say we're buying 2 bottles, 2 times 2 equals 4. So that comes out correct for Y again. 2 times 3, if we're putting in 3 bottles, comes out as 6. So this equation does accurately reflect the situation. And then if we wanted to say, we're going to buy 100 bottles, 2 times X, that's why we don't use a multiplication sign for this. 2 times X equals Y. We could say for 100 bottles, 2 times 100 equals 200.